So you have your test on Monday. Tomorrow is going to be hopefully just, we're gonna go over the homework and then review game tomorrow. So today, I just wanted to start with this review sheet. I'm gonna go kind of quick because you guys did have some time to work on it on your own. So I kept it simple for weathering. And I just wrote down the breaking. If you went further, did somebody go further? What'd you say, Carter?
The breakdown of rocks into smaller.
Yeah, so the breakdown of rocks into smaller pieces, probably a better definition than mine, but I was getting kind of lazy. Breaking is good enough. Chemical weathering. I went with the breakdown of rocks by changing chemical composition. Did anybody else include some more in that?
Yeah, I put warm, moist.
Okay, so you put warm, moist climate. I did end up putting that down here in the differences. Either one is fine with me. So warm, moist climate. Anybody else add anything else for chemical weathering? Happens on the surface of the rock. That would be great too. Yeah. All right, then for physical weathering, I said does not change the chemical composition.
Cold, moist, dry.
You could put cold, moist climate. I did put that over here in the differences. Same there. So with erosion, I kept it simple. It's the moving of sediments. So I would make sure you at least have the bare minimum like I have here. If you went further, that's great. But at least have what I have. The 5 agents of erosion, I kept the W's together. Water, wind, waves. If anyone ever wants to work together or sit near their friends again, I hope you're paying attention. So water, wind, and waves. Gravity. I also added that gravity is mass movement. If you can remember that, maybe you don't need to add it, but if you can't remember, maybe add it right here. Gravity, mass movement. So gravity and glaciers are the 2 G's. A bunch of you got stuck with the rocks eroded by gravity are, and I did put in parentheses, I wanted you to tell me how they look. So imagine I take a rock and I drop it and gravity takes charge. When it hits the ground, how is it gonna look when it's broken? Jagged. And a bunch of you said smaller, that's also true. But what I want you to keep in mind that it's not going to be round. So if you wrote jagged, that's great. If you wrote angular, that's great. Don't write round. That's wrong.
Round.
No, don't write round. And then examples, they are unsorted. And I didn't put anything for examples. What'd you include there? Mudslides work.
Cliffs.
Mudslides. Cliffs. Rocks at the bottom of a hill, I think is what you guys said. So anything. Yeah, I heard some people answer, but I'll call in some other people. Deposition by waves, they're sorted. Big waves pick up big, strong, heavy things. That is, they move by longshore currents, and they create beaches, sandbars, barrier islands. Glaciers are unsorted. They create U-shaped valleys, moraines, grooves, or striations. And then wind is sorted, and the biggest thing they make are sand dunes. Does anybody need me to repeat anything or hold on? On the back where it said sand dunes, did you need me to wait when I said, do you need me to wait? Okay. On the back when it said sand dunes, I wanted you to draw me pictures. So I drew 2 different pictures. What is the key? Where is the wind?
Left and right.
Well, how do I know? Is it the left or the right?
Because that's the where you can walk up.
Okay, the easy to walk up side. It's the wind on the gentle slope. Gentle slope. So it's always on the longer side, not the steep side. Running water creates those V-shaped valleys, deltas, and meanders. Sediments deposited by water are smaller, smoother, and rounder. They're also sorted. I do want you to have all of that there, so I'll give you a second to add that if you didn't. Sediments are smaller, smoother, and rounder. This question here was just like your homework. So again, if it says how fast does the water have to be moving to carry something that is 0.1 centimeters?
5 centimeters.
0.1 centimeters go over. So again, make sure you find which side. It was 0.1 centimeters, that's here. Go over till you hit the line, go down 5 centimeters per second. Be sure to include the label. And then the next one said, sorry, the next,
Definitely from the side of sediment that is smooth, long, and smooth.
10 centimeters per second. So 10 centimeters per second, go up till you hit the line. That one so conveniently hits right on the 0.2 centimeters. All right. This one is just review of what we've been talking about. On the outside of a meander, water is moving faster. Because of this, there's more erosion. And because of this, the stream is deeper on the outside of a meander. The next one, again, is the same idea. On the inside of a meander, the water is moving slower. And because of this, there's more deposition. And because of this, the stream is shallower or more shallow, I think is the proper way of saying that. I'm good with shallower. Now, this is where we left off yesterday. If you guys could return to the seats, I decided to print you your own Ritz River. No, it's Ritz River.
It's still really.
Anyway, grab that and the paper we were on page 26 where we were yesterday. If you are comfortable there, just get up and get your river.
Okay. I don't have a rest.
You can sit at that table. If you don't have a Ritz River, there are plenty scattered around. Okay, so in our class, we did not get through drawing all the examples. In fact, I think we only did A, didn't we? So let's review with A. So we talked about this yesterday. A is on a curve. Because A is on a curve, what do we know about the inside and the outside of that curve? Where is it moving faster? Let's start there. Okay, so A is, wait, which one's the outside?
A prime.
A prime is the outside. So go right ahead on your Ritz River and label that as the outside. Because it's the outside, what happens on the outside? Okay, it's faster. Because it's faster, what's happening? More erosion. And because there's more erosion, what do we know about the depth? It's deeper. I would like you to, yes. And what about for A then? Where is A on the curve? This is the inside of the curve is what I'm getting at. Because it's the inside, what's happening there? Moves slower. And when water's moving slower, it starts to drop off sediment. So there's more deposition. And because things are getting dropped off, yes, Zach was right that it's going to be shallower or more shallow. So what did that mean for our picture of the river? So these are going to be either called cross sections or profiles of the river. And how I had you do it was we started with a dot near the deepest, or for the deepest part of the river. One thing that I'm not sure was clear is up here is the surface of the water. So the tops of these boxes are where you would float in a floaty. Hey, that sounds like more fun than doing earth science, floating down a river on a nice day.
Oh, absolutely.
It does. Sounds awesome. So your floaty's up here. I want you though to draw the bottom of the river. So we start with the deepest spot. Where did we say the deepest spot's gonna be? Closer to A prime because that's the outside of the curve. Now it's not right on A prime, it's off to the side a little bit. And then once you label the deepest spot, if you just connect that with the top boxes, you'll get that V-shaped valley that the river creates. That's on page 26. So this is page 26. This is not our review sheet. So why doesn't everybody grab page 26? We already did A prime, or A and A prime. Now let's take a look at B. What do we notice about where B is? Is it on a curve?
No.
That spot is a straightaway. So if you were in that floaty, when you were here at A and A prime, you're going around a curve. But if you're in that floaty, just traveling by B, your body's just moving straight through that area. So that's a straightaway. On a straightaway, where's the deepest spot gonna be? Are we moving faster or slower on a side here? No, on straightaways. It's not, right, it's the same on each side, meaning the deepest spot is going to be in the dead smack center. Now, I'm not sure why this B prime got moved over. It should still be over to the edge, not super important, but. So the dead smack center this time is the deepest spot. And when you connect it, just like Sarah said, the sides are going to be the same. It does. They all are making V's. It's just which side the V is kind of like pushed over to. So what about C to C prime? Take a look at that sucker. Or first of all, are we on a curve or a straightaway? That's a what? A curve. C and C prime, if you're floating down this river. No, right here, this area is a curve. So your body is going to be flung to one side of the river if you were floating down this river. Which side will it be flung to? C. Why C? Because it's the outside of a curve. So it's moving faster on the outside. So C. More erosion's happening at C. So what do we know about the depth? Deeper at C. So we go back to our profile. Where do I put the dot? Closer to C. And when you connect them up, again, you get the steep side on C and a gentle side on C prime. How about D? If you are floating down this river and you're going by D and D prime, where are you on a river? You're on a straightaway. And on a straightaway, where's the deepest spot? In the middle. So we go back. D is going to look just like B. Straightaways are faster. And they're fastest in the middle because they don't have to, when you're on the edges in a straightaway, you are getting some friction from the banks of the river. So it does go a little bit slower on the banks than it does in the middle. All right, how about E to E prime? Curve or straightaway? That's a curve. Where is the deepest side going to be on that one? Why is it going to be at E prime? That's the outside. The outside is E prime. So again, the deepest spot, closer to E prime. Connect them up. Now on our review sheet, so back to the review sheet, sorry for the jumping around. On the review sheet, I gave you a little river in this box. And then I asked you to draw 3 profiles, one for the A area, one for the B's area, one for the C. I would like you to try them on your own. So think about, and just to get you started, if you wanted to draw those boxes again, keeping in mind, so A and the prime, so A's and B's, the regular ones will be on the left, the primes are on the right. And you can put the letters on the top or the bottom, just make sure they're making those V shapes, not mountains.
That's right. I'm confused.
You are already, you're just walk me through all of the examples though.
I know, so I'm just drawing and saying that can have it on paper.
Well, you gotta make sure it matches with that river. This river.
Oh,
Oh,
that way.
that river. So we're looking No, so if this was you floating in a floaty, you're going straight. Yeah, so a couple people have now got a little confused. So is a straightaway or a curve? What I want you to picture is yourself in a floaty. If you were floating down and passing by A and A prime, that is, so if you're just traveling right here, you're not turning. You're going nice and straight there at A.
He's a curve, right?
A is a curve, or A is a straightaway, yes. At C, you're going right around that curve if that was you. So you would be drawing, your body would be doing this, going around there. What else did you ask that? B is also a curve.
What do you mean homework review sheet?
I haven't passed it out yet.
Oh, I thought this was your-
No, well, this is, yeah, so you guys already did half the homework. All right, so since A is a straightaway, where's the deepest spot?
In the middle.
In the middle. So that's just gonna be a perfect V. B is a curve. So if we have B and then B prime over here, which one's on the outside? In this case, B is the outside. So since B is the outside, what do we know about B? It's deeper, closer to B. So if we were to make that, it would be a steep slope and then a gentle slope. And you probably should have drawn the box to make it. If you didn't draw the box, just make sure it really looks like steep and then gentle. How about C to C prime?
That's a straightaway.
That is a curve. Which one's the outside? C prime is the outside. So if C prime is the outside, what do we know about that? Deeper, faster and deeper over by C prime. So that is officially it for the chapter, really. We got one thing we're gonna look at real quick tomorrow. I do just want to make sure you have the answers to last night's homework. So there is homework tonight. You have 11 questions for homework tonight.
Is there homework tomorrow?
No,
Well, everything on meetings.
I just do it to make you happy. We are running out of time. So I'm gonna start by just giving you the answers, and if there's any you want me to go over, let me know. So let's start with number 1. I'll wait for you guys to grab it. Number 1, if the velocity was 100 centimeters per second, the biggest thing it could carry is answer 3, a pebble. Number 2, if it's going 200 centimeters per second, the biggest thing it could carry is a cobble, answer 2. Number 3, how fast does it have to move us 1 centimeter particle? That's answer 1, 50 centimeters per second. Number 4, up at the top, so it was going 300. It drops to 200. What's it gonna drop off? Boulders. So at 300, it can carry everything, but at 200, it can't carry boulders, so it drops them off. And as stream sediments decrease, the amount of sediments also decrease.
Oh, 100%.
Number 6, what controls the sorting? That's because the velocity changed. That's good. And then because, so what's happening along the x-axis? It's the water's going faster, so there's going to be more erosion.
Yes, sir.
Ow, knocking it out of the park. So 75 centimeters per second can carry pebbles, sand, silt, and clay only. So no cobbles or boulders. Number 9. Velocity of 100 centimeters per second flows into the lake. What will be dropped off first? Pebbles. Not boulders and cobbles, because at 100 centimeters per second, it wasn't carrying those in the first place. All right, number 10. When we drop from 300 to 5 centimeters per second, or when it goes from, sorry, the other way around, it starts at 5 and it goes to 300. Answer 1, sand is going to be picked up. 5 centimeters per second is already carrying silt. So the first thing it's going to pick up is sand. Already carrying it, so it's not going to pick it up still. And then which one will remain suspended the longest, meaning which one will go out into the lake the furthest? That's clay, because it's the smallest. Here is how they throw in stuff from chapter 2, or actually 3. They say which one's going to make siltstone. So remember, silt makes siltstone. So silt is found in this area from 0.0004 to 0.006. So that will make siltstone, answer 3.
Dang
And then
it.
finally, as velocity increases, particle diameter also increases.
My God.
All right, I am going to pass your homework. It is one sheet of paper back in front. It is recent questions. Yeah, they are multiple choice, but like I said every time, there's only 11. Put some effort into it. Try it, because these might look exactly like that question. Oh,
Yeah,
yeah,
I need
one.
Oh, no, then you'll just.
Did everybody get one? So again, your homework, since we already did the review sheet, your homework is just the questions 1 through 11.
Some people have.
Yes, some classes we did not do the review sheet right away. Well, they actually got the 20 minutes to work on it at the end, but we didn't go over it, is what happened.